Greetings and welcome to Train Signal. You're watching Exchange 2013 High Availability and Site Resilience. In this lesson, we're going to discuss high availability and site resilience, and we're going to talk about a feature that's built right into Exchange 2013 called Database Availability Groups. Now, my Latin may be a bit rusty, but there's a Latin adage that says Si vis pacem, para bellum, and it's translated as if you wish for peace, prepare for war. And in the context of Exchange, we really appreciate that there are any number of reasons why we might lose availability. It might be a database issue, perhaps the database has become corrupt. It might be a server issue, perhaps the server has gone down. It might be a power issue, perhaps the entire building or the entire city has lost power. And so, really, the best way to ensure availability is through redundancy. So you have to look at disk, server, and site redundancy. And built right into Exchange 2013 is this Database Availability Group feature, or DAG feature, that really helps to provide increased availability depending on how you design and deploy the solution. Now, in this lesson, we're going to discuss the basic concepts of database availability groups and how you might utilize this, and we're going to demonstrate a two-server DAG setup. So we're not really going to deep dive here and really map out all of the different design and deployment scenarios that you might utilize. Nevertheless, this is a good starting point for understanding high availability and site resilience features that are built into Exchange 2013. Okay, so let's get started. In a previous lesson, we have discussed Exchange storage architecture, and so it's important to revisit that information, because to truly understand how Exchange 2013 eliminates the need for perhaps even disaster recovery, you have to visualize the technology in place. So you'll recall we talked about how there's a database file, and there's one database file for each database. It's an EDB file. At the same time, there are transaction logs, and these are 1 megabyte in size, and these work together to provide a consistent storage. So understanding this concept, how email comes into the server, gets written into transaction logs, and then those logs are then written into the database itself, is very helpful when it comes to understanding how Exchange utilizes this same concept for high availability through a feature called continuous replication. With continuous replication, the database is initially copied over to another server, and then the log files are shipped and replayed constantly to keep that secondary passive copy of the database up to date. So you have your active database, which is the one where persons are actually accessing it for their mailbox information, and then you have this passive copy that is on one or more systems that have the logs then shipped over to the system, and those logs are played into that copy. So in the event there was ever a problem with System 1, and in some way System 1 went down, the active copy would cease being on System 1, it would automatically fail over to System 2, and then System 2 would be able to take over and continue to serve users with their mailbox content. Now you might be thinking, well, does any of that content get lost in the process? Yes, it is possible for the two databases not to be exactly in sync, especially depending on when the system goes down and what email might be in transit during that time. But there are features in place that are designed to mitigate that so that as little data as possible is lost should System 1 go down. At the same time, we say that there's an automatic failover from System 1 over to System 2. There are also times, for example, if System 2 is located in another site, and depending on the design and deployment of the database availability group, there are times when you might need to perform a manual switchover from System 1 over to System 2. But before we get too deep into the terminology and concepts of a database availability group, let's define it, and then let's see if we can take a look at what this might look like from a visual perspective. So the high availability feature that's used in Exchange 2013 is called a Database Availability Group, or a DAG. A DAG uses continuous replication. So the database is copied over to another location, another mailbox server, and then the transaction logs are continuously shipped over and replayed into the passive copy of that database. DAGs allow for up to 16 mailbox servers that host a set of these replicated databases. Now you have that active database, and if that fails, an automatic failover to a passive database is possible thanks to what's called an active manager, which is an Exchange component that's running inside the Exchange replication service. In addition to passive copies, you can also have passive copies that are lagged, and a lagged copy is a copy of the database that is not kept up to the moment, and transaction logs are not replayed immediately into those lagged copies. The benefit of this is that in the event there's a virus or some type of corruption that is now propagating from your active database off to these passive databases, utilizing a lagged copy ensures that you have a little bit of time so that if you do need to stop the replication to ensure that that database is not corrupted and doesn't have that virus sent to it, you have at least a window of opportunity depending on how long you set the lag time for. Let's take a look at this visually because it might make a little bit more sense. Okay, so here you can see within Site 1 we have three different systems: System 1, System 2, and System 3. And each system has a database that is an active database, DB1, DB2, and DB3. So what we have here is just a basic setup where these three systems are part of the same database availability group. All three are members of that group. And so what we've done is we have a passive copy of database 1 located on System 2. On System 3, we have another passive copy that's a lagged passive copy in the sense that we've established it so that transaction logs are 24 hours behind the passive copy on System 2. Now, why did I choose 24 hours? Well, it was just an example. It could be 7 hours, it could be 3 hours, it could be 1 hour. It could be that you have multiple lagged copies that utilize different time frames depending on the number of lagged copies that you feel is appropriate. So this is something that is all part of design and deployment. It's not something that has to be determined right now this very second, because in some cases some organizations don't use lagged copies at all. If we look at database 2, we've done the same thing. We have a passive copy that's up to the moment on System 1, and we have a lagged copy on System 3 that also is 24 hours lagged. Database 3, same thing. We have a passive copy on System 2 and then a lagged copy on System 1. So if you're looking at this and let's say System 2 goes down, this does not affect the active database for System 1 or 3. And the passive database for System 2 that's located on System 1, that will automatically become the active copy of the database, because in this case it's a single site, and as part of a database availability group, it would automatically fail over to System 1. Now this may all sound very scary, and you might think the process for creating a database availability group must be overwhelming. Well, let's take a look at the process, because you'll see that it's not as overwhelming as you might think. Establishing a database availability group is really a three-step process. First, you create a database availability group. Second, you add mailbox servers to the database availability group. And third, you determine passive copies of your active database or databases. Worrying about whether or not you make those lagged copies or not is something that you can do later on. But to establish a DAG and ensure that your databases are protected, really it just involves these three simple steps. Now certainly there's much more to database availability groups, but that's all part of Database Availability Group or DAG design and deployment. And the design depends on the number of servers and the number of sites that you have to work with. But overall, establishing a DAG is done through the EAC or the EMS, the Exchange Admin Center or the Exchange Management Shell. To really master high availability within Exchange 2013, there are a lot of new terms that are going to be coming your way. For example, when we set up the DAG, you're going to see that it asks us which server will be the witness server and where the witness directory will be. The DAG witness server and the directory, these are only used for quorum purposes when you have an even number of DAG members. Now, what does that mean? Well, if you have two servers, Mailbox Server 1 and Mailbox Server 2, and Mailbox Server 1 has the active copy and Mailbox Server 2 has the passive copy. If Mailbox Server 1 goes down, Mailbox Server 2 wants to take over immediately and begin serving because that's its whole purpose. And so this is all established based upon the concepts of a cluster. So you have these two servers and the one wants to go right to work. But what if Server 1 didn't go down? What if perhaps there was just a communication glitch? What if, let's say, the network connection between Server 1 and 2 is what went down? What could happen if Mailbox Server 2 decides to take its passive copy of the database and make it active? What if both servers believe that they have the active copy of the same database? Well, that creates a problem that's called split brain syndrome. And really, this would be catastrophic in terms of the data, because where would email go to and where would email go to, which copy of the database, and how would users access their mail? And there's all sorts of other issues that can come from this in terms of the data itself. So we don't want that. So how do we avoid this problem? Well, the only way to avoid this problem when you have two DAG members is to have a witness server. That witness server ensures quorum. In other words, there's a referee in play now. Now this witness server cannot be a member of the DAG as well. If you had an odd number of DAG members, let's say 3 DAG members instead of 2, well, then you have a quorum. But if you only have 2 members, which in smaller environments that's what you're going to have, then you would need to have a witness server to ensure that there's quorum. And this way, if Mailbox Server 1 isn't really down and Mailbox Server 2 wants to take over, it will check with the witness server, and the witness server would be able to respond back and say, hey, wait a minute, I do have connectivity to Mailbox Server 1, and so don't become the active just yet. And so that would prevent split brain syndrome. Going back to our scenario with SpyTech Prime, what we've done is we've added a secondary mailbox server to our environment, POS EX2K13 MB2, and it will serve as the location for the passive copy of our active database located on POS EX2K13. So based upon this, we will create a database availability group. We will assign 2 members, POS EX2K13 and POS EX2K13 MB2, and we will establish the passive copy. Let's see this from a diagram perspective. Looking at the scenario from a diagram perspective, what we're going to do here is we're going to have the domain controller itself be our witness server. We're going to have the 2 servers as part of the DAG, and we're going to have database 2, which is our active database with all of our mailbox recipients in that database, have a passive copy established on mailbox 2. Alright, so let's get to work. Alright, so here we are on our Exchange server. If we open up our Exchange Admin Center, we can go to Servers, and from here if we click Servers, you can see that we have that second server set up, and it's just a mailbox server. It's not a client access server as well. And so we're going to utilize this server as our passive copy server for our Database 2 database. If we click Databases, you can see that we have 2 databases on POS EX2K13 and 2 databases on POS EX2K13 MB2. That doesn't really matter. Really, it's this database 2 that we're concerned about because this is the one that has all of our recipients. So we're going to ensure that we have a passive copy of this database on POS EX2K13 MB2. It all starts with the Database Availability Groups tab. We select that. We can see we have no database availability groups established just yet. We click the plus sign. We're going to give it a name. In this case, we'll just call it POS DAG. And you can see it says that you use this field to type a valid and unique name for the DAG of up to 15 characters. The name is equivalent to a computer name, and a corresponding cluster network object, CNO, will be created in Active Directory with the name of the DAG. Now, this is interesting because in some cases, depending on your setup, if you're using a server running 2008 R2, for example, you might have to go into Active Directory and create this CNO within Active Directory manually. and you would need to make sure you assign permissions to the Exchange subsystem and so forth. So depending on what type of server setup you have, you may need to create this manually. And then you would come here and then use the same name as part of the DAG. As for the witness server, notice it says that the witness server is a required property. It is used only when the DAG contains an even number of members. Enter the name or FQDN of the server that will be used as the witness server for this DAG. So in this case, we're actually using POS DC1 and the witness directory. This is interesting because we can leave this blank. And if we do leave the field blank, the default path will be used, it says. Now, the default directory is actually the system drive and a folder that's created called DAG File Share Witnesses. If you don't want to use the default path, and let's say you have a specific path you wish to use, you can put that in here. In our case, we're going to go with the default path. Then we can add an IP address, and it says a DAG must either be assigned one or more static IP addresses or be configured to use Dynamic Host Configuration Protocol. So either way, if you leave this blank, it will use DHCP to configure IPv4 addresses for the DAG. So in the interest of simplicity, we'll leave this as is. We'll leave it as using DHCP, and we click Save. Alright, and so we have our DAG created, but you'll note that there are no member servers here. So if you look here, we can select this little icon, New DAG Membership. And from here, we're going to add in the 2 mailbox servers that are going to be part of our DAG. And we click OK. And then Save. Notice it says the task is installing the Windows Failover Clustering component on server POS EX2K13. Under the hood, Exchange uses failover clustering components in order to accomplish the creation and use of the database availability group. And now it's forming the cluster. It's now adding the second server to the database availability group. Obviously, the Windows Failover Clustering component has to be added to the secondary mailbox server as well. And it says we've completed the operation. We click Close. And now you can see we have the DAG and we have the member servers here. And so if we expand this here and look inside, we can see that we can make some changes. We can add additional servers to the DAG at any time, up to 16 different servers. We can see if they're operational or not. We can look at the IP address and we can change it from DHCP over to static addresses that we add in. So this is great. We're all set. We have member servers, we have our witness server, we have our DAG network. We're good to go. The next part of the process is to actually take one of our databases and make a passive copy from one server over to the other. So we actually do that not from here, but from databases, and the database that we're concerned about is database 2. Now, because we have now established a database availability group, when we click the 3 dots here, it used to just say dismount database, but now notice we have add database copy. So this is a new addition because it's part of a database availability group. So we click the add database copy, and here it says we can specify the mailbox server. So we're going to browse. There's only one that we can actually create a copy on because there's only 2 members of this DAG. We click OK. It mentions there's an activation preference number. This is not what folks think it is. Here, if we select this, it says it's used as part of the Active Manager's best copy selection process and to redistribute active mailbox databases when balancing the DAG. So in this case, we'll leave it as number 2. In different scenarios, you can work with the activation preference number to try to manage what system gets failed over to first, but really in the end, the preference is just a preference. The Active Manager really has a lot to consider when it comes to which server to fail over to, and so that's actually something that's done automatically through the Active Manager. So this preference does not make it a hard and fast rule that this will be the server that gets failed over to. Certainly in our case, it's going to be the server that gets failed over to, because in our case we only have the 2 servers. So if this one goes down, it will go over to Mailbox Server 2. But just from a larger perspective, this preference number is just a preference. The preference number is just a preference. It's the Active Manager that makes the final call. We click Save. Notice the process of making that initial copy from the one server over to the other is called seeding. So that's important to note that that is the term that's used for that initial copy. And then from this point forward, once the copy is created and there's that database, the passive database, over on the secondary server, then the updates are done through that continuous replication transaction log shipping and replaying into the passive copy of the database. Okay, and so saving completed successfully. You've completed the operation. We click Close. And now we can see that when we select the database and we look at the details pane, there's more information for us here with regard to the passive copy here, as far as the copy queue length, the content index state. All of this will be updated momentarily as it begins to synchronize there. But now you can see the difference between a regular database, which just gives you a little bit of information here, and one that has a passive copy that is, as you notice, synchronizing. The index state is healthy. So this will update itself, and you'll be able to get at-a-glance information regarding the status of your passive copies through the details pane over here on the right. Now, if you're thinking for a moment, is this it? Wow, this is really easy. High availability through database availability groups is the easiest thing I've seen in Exchange. Well, okay, remember that this is just a single lesson, and it's meant to appear easy so that you get your feet wet with the concept of high availability. But keep in mind, there are a lot of things we have not gone into. We really have not outlined what the Active Manager does. We really have not gone into the network stipulations here as far as your network that's set up for the database availability group. We have not discussed redundancy in that regard. And when it comes to high availability, we have really not looked into all of the other pieces to the puzzle to ensure complete availability. For example, we have a single instance of a client access server in our environment. Well, if the client access server goes down, don't we lose availability there too? We certainly do. So having a database availability group is great for our mailbox server, but what do we do about the client access server? Well, obviously we need redundancy of that as well. And in those cases, we also want to consider things like a load balancer that can handle balancing the load between your client access servers. So that's another discussion. And then in terms of the environment itself, what about redundancy of your routers? What about redundancy when it comes to power, when it comes to network and internet access? All of these things come into play. And then obviously, as you expand and perhaps have multiple branch offices, and you might spread this database availability group out across multiple sites, or perhaps from your primary data center over to a secondary data center. You see, there's a lot of design that goes into this depending upon your environment. So all we've done here in this lesson is defined the basic shell of what a database availability group can do for an organization on a small scale. All we've done is utilize 2 mailbox servers and establish a very simple database availability group where we now have a copy of our active database with all of our recipients and their email over on a secondary server as a passive copy. Is this awesome? It absolutely is awesome. It's wonderful to know that that data is safe. However, that's not the be-all and end-all of database availability groups. This is an entire course in and of itself. But let's rejoice in the fact that we have discussed high availability in Exchange 2013 through database availability groups, and you've had an opportunity to see it demonstrated right here before your eyes. So we hope you found this informative. Thanks for watching, and I'll see you in the next lesson.